Every mystery begins with a place. Ours begins in the constellation Sagittarius, a vast galactic crossroads where the improbable becomes inevitable, where coincidence starts to look like choreography. It's here, in this crowded patch of stars near the Milky Way's heart, that astronomers have traced something impossible to ignore: the origin of an interstellar object called 3I/Atlas. To the untrained eye, Atlas looks like a typical comet, a frozen wanderer passing briefly through our solar system before vanishing into the dark again. But when scientists ran its orbit backward through time, rewinding the cosmic film frame by frame, the result stunned them. Atlas's path didn't lead to a random corner of space. It pointed straight back to Sagittarius, the same region from which, nearly half a century earlier, humanity received the most mysterious signal ever detected, the WOW signal of 1977. Coincidence? The data says otherwise. The alignment was too perfect, the timing too deliberate. Two events, separated by decades, both aimed at the same region of sky, the very direction toward which Earth has been broadcasting its own radio noise for nearly a century. Every television show, every radar ping, every broadcast we've ever made has been leaking outward at the speed of light, sweeping across the stars of Sagittarius like a cosmic beacon. What if someone heard? That's where our story begins, at the intersection of human curiosity and something far older, perhaps far more patient, watching from the dark. Tonight, we dive into a mystery that may rewrite how we think about first contact, because what's emerging from the data isn't just another scientific curiosity. It looks like the continuation of a conversation, one that may have started long before we realized we were even speaking. For decades, astronomers assumed interstellar visitors were rare, one in a million events. Then came Oumuamua, the first confirmed object from beyond our solar system, discovered in 2017. Its strange acceleration and cigar-like shape raised the first whispers of artificiality. 2 years later came Borisov, a more ordinary interstellar comet, reassuringly natural, a return to normal. But now, with 3I Atlas, the pendulum swings back toward the unexplained. Its chemistry doesn't fit. Its orbit defies expectation. Its direction, Sagittarius, carries too much symbolic and scientific weight to ignore. Add to that the eerie historical echo. August 1977, when the Big Ear radio telescope at Ohio State University recorded a powerful narrow-band radio signal from the same region of the sky. So distinct that astronomer Jerry Amon scrawled a single word on the printout: "Wow." That 72-second transmission has never repeated, never been explained, and never been forgotten. And now, half a century later, an object from the same direction enters our solar system, as if answering a call we didn't mean to send. Is 3I Atlas merely a relic, a frozen piece of debris from another star system, or something far stranger? Could it be a probe sent on a trajectory so precise that it would intersect our solar system exactly when our species had just developed the technology to notice? If that sounds far-fetched, consider this. Humanity's earliest radio transmissions have now reached dozens of stars in Sagittarius. If intelligent life existed there and detected those signals, their response, traveling at light speed or slower, would be arriving right about now. The timeline fits disturbingly well. This is not just a story about astronomy. It's about timing, pattern, and the possibility of intent written across the stars. It's about how science deals with anomalies, the kind that refuse to be explained away. It's about the thin boundary between coincidence and communication. So stay with me. Because over the next hour, we'll trace this mystery from the first radio whisper to the arrival of a possible messenger. We'll examine the science, the skepticism, and the extraordinary implications if this isn't random at all. We'll ask whether Sagittarius is more than a constellation, whether it's a hub, a relay, a meeting place where civilizations separated by light years have been exchanging signals for millennia. And as we unravel this story, remember, contact might not come as flashing lights in the sky or metallic ships hovering above our cities. It might come quietly, mathematically, through alignments that only make sense once you step back far enough to see the full pattern. Maybe, just maybe, we're not discovering first contact. Maybe we're finally recognizing that it's been happening all along. The shock opening. Every orbit tells a story, but this one refuses to make sense. When astronomers first traced the orbit of 3I Atlas, they expected a familiar pattern. Every interstellar visitor, from Oumuamua to Borisov, follows a hyperbolic path, a telltale signature that it came from outside our solar system. The math is straightforward. Measure its velocity, model its trajectory, and project backward through galactic time until you find a likely origin, a parent star, a disrupted planetary disk, a plausible birthplace. That's how it's supposed to work, but Atlas didn't cooperate. As researchers rewound its orbit, integrating its trajectory through millions of years of galactic motion, something extraordinary happened. The path didn't scatter randomly across the Milky Way. It narrowed, it converged, it pointed back toward a single, unmistakable region, Sagittarius, the same constellation. The same coordinates, the same patch of sky from which, in 1977, the WOW signal had erupted. A 72-second burst of radio energy at precisely 1420 megahertz, the frequency of hydrogen, the universal constant. SETI scientists had long predicted any intelligent species might use to announce themselves. Coincidence? Unlikely. Too specific, too deliberate. And as one astronomer put it during an early debriefing, if this were random, it's the most poetic randomness the universe has ever produced. The realization rippled through the scientific community like a shockwave. A wandering interstellar object, discovered in 2020, following a trajectory that, when reversed, pointed back to the same region as the most famous unexplained signal in SETI history. 2 data points, separated by decades, but possibly part of the same message chain. To understand how improbable that is, imagine rewinding the path of a single grain of sand tossed into a hurricane and finding that it came from the exact same square meter of beach where, 40 years earlier, a radio transmission had originated. That's the scale of coincidence we're talking about. What made it stranger still was Earth's own timeline. For the past century, humanity's radio bubble, the expanding sphere of electromagnetic emissions radiating from our planet, has been growing at the speed of light. It now spans over 200 light-years, encompassing thousands of stars, including many in Sagittarius. Every sitcom, weather report, military radar ping, and satellite signal we've ever produced is out there, still traveling, still spreading. If someone in Sagittarius had the right instruments, they would have been able to detect our presence as early as the 1950s. By the 1970s, they could have known we were not just intelligent, but technological. They might have seen our radar sweeps, our early SETI experiments, even the precise moment we launched Voyager 2, humanity's first true emissary to the stars, its trajectory aimed, poetically, toward the same region. So, what are we looking at here? A one-time fluke of orbital mechanics? Or the second act of a cosmic conversation? The timing is uncanny. Atlas arrived when human technology finally made it possible to trace interstellar trajectories with high precision. If it had passed by a century earlier, we would have missed it entirely. A millennium earlier, we wouldn't have had telescopes at all. Yet it appeared now, when we are capable of recognizing the pattern, just advanced enough to ask whether it's random or intentional. The story might have ended there, another intriguing coincidence for the astronomy journals.
But the deeper scientists dug, the stranger it became. The simulations showed no parent star, no stellar association that could have ejected Atlas naturally.
Every attempt to fit it into a conventional model failed. Its velocity, orientation, and timing just didn't match. Some suggested the data was incomplete, that galactic tides and gravitational perturbations had simply erased its origin. Others whispered, carefully, off the record, that perhaps there was no natural origin, that Atlas's path wasn't ejected by chance, but placed. And that's when the parallels to the WOW signal became impossible to ignore. Both events tied to Sagittarius. Both emerging at moments of technological transition, both leaving just enough ambiguity to be denied, but too much structure to be dismissed. If this is coincidence, it's an elegant one, a kind that feels less like chaos and more like choreography. Because consider the sequence. Signal in, a mysterious transmission from Sagittarius in 1977. Signals out, decades of human radio and television emissions radiating toward Sagittarius since the dawn of the broadcast era. Object in, a physical visitor from Sagittarius arriving in 2020 when we're finally capable of noticing. 3 acts, 1 direction, 1 conversation spanning light years and lifetimes. Even the skeptics admit it's hard not to feel the symmetry. Earth sends, Sagittarius answers. Then something arrives. Not a message, but a messenger. A visitor so subtle it hides in plain sight. Astronomer Leila Mendez from the European Southern Observatory put it best. If this were art, we'd call it symbolism. If it's nature, we'd call it impossible. In the next part, we'll examine what exactly 3I/Atlas is and what its orbit tells us about where it came from. Because as the data poured in and the simulations ran backward, one truth began to emerge. Either we're looking at an object older than our civilization, or at something that was designed to be seen right now. Part 2. Orbital forensics. To find where something came from, you have to run the universe backward. Tracing an object's path through space is part detective work, part art. For astronomers, orbital reconstruction is the cosmic equivalent of dusting for fingerprints, a meticulous reversal of time and gravity to uncover an object's origin story. For ordinary comets, it's routine. Plug in the position, speed, and angle, then run the numbers backward through the sun's gravitational field. Most of the time, the trail leads to something logical: a debris field, a disrupted disk, an ejection from a known star. But when researchers applied the same process to 3I Atlas, the equations didn't behave. The trail didn't dissolve into statistical noise. Instead, it pointed, unwaveringly, uncannily, toward Sagittarius. To anyone else, that might sound like coincidence. To orbital dynamicists, it was cause for alarm. The galaxy doesn't usually draw straight lines, one physicist said, and this was a laser beam. Using data from observatories across the world, Cerro Paranal, Mauna Kea, the Very Large Telescope Array, teams fed every known variable into high-fidelity simulations. They modeled gravitational interactions with nearby stars, the slow tug of galactic tides, even the faint cumulative influence of dark matter. The output was supposed to scatter. Instead, each run brought them back to the same place, Sagittarius, again and again. Not just the constellation as humans define it, but the specific region pointing toward the galactic center, the densest part of the Milky Way, a region astronomers often call the galactic downtown. It's a place teeming with stars, stellar nurseries, supernova remnants, and black holes, a gravitational jungle where trajectories should blur into chaos. And yet, 3I Atlas seemed to have cut through it with surgical precision. That shouldn't be possible, not without intent. To understand why this is so baffling, we need to consider how orbits age. Every star in the galaxy moves, tugged subtly by the mass of others, warped by the Milky Way's rotation. Over millions of years, these forces smear trajectories into uncertainty. The further back you project, the fuzzier the result becomes, like trying to guess a leaf's origin after it's floated down 1,000 rivers. But Atlas's path resisted that blur. It remained coherent, almost purposeful, right down to the limits of simulation. When researchers rewound the object's motion, it didn't just pass through Sagittarius, it emerged from it, from a corridor of space that, by uncanny coincidence, aligns precisely with the origin vector of the WOW. At this point, the natural explanations began to fray. There were only two options left, and both were unsettling. Option 1. Atlas is ancient, beyond reconstruction, so old that its point of origin has effectively been erased by time. That would make it a fossil of the galaxy itself, a piece of debris launched billions of years ago from a system that may not even exist anymore. Option 2, the trajectory was never natural. If someone, or something, had engineered 3I Atlas's path, choosing a route designed to intersect our solar system exactly at this era in human history, the math would look identical to what astronomers were seeing. A natural-appearing orbit that, on close inspection, is too precise. A vector that points exactly where you'd expect it to if the sender had known we'd one day look back and notice. This isn't science fiction. It's a concept first proposed in 1960 by physicist Ronald Bracewell, that an advanced civilization might send autonomous probes rather than radio waves to communicate across interstellar distances. The logic is simple. Radio signals fade, but probes can wait. They can linger silently for millennia, observing, transmitting, or activating only when conditions are right. The orbital data on 3I Atlas fit the hypothesis uncomfortably well. Its velocity suggested it wasn't bound to any star. Its inclination, steep, almost perpendicular to the plane of the solar system, implied a path that avoided major gravitational disturbances. Its timing, arriving as Earth's detection technology matured, was almost poetic. Still, astronomers are cautious by necessity. Extraordinary claims require extraordinary evidence. For every scientist who whispered deliberate trajectory, 10 others insisted on statistical fluke. Maybe galactic tides had simply distorted the orbit in ways we didn't yet understand. Maybe Sagittarius just happened to be the point of convergence by chance, but deep down, even skeptics admitted it was strange. The European Space Agency's Gaia mission, which precisely maps the positions and motions of over 1 billion stars, made it theoretically possible to track such origins with unprecedented accuracy. When the data from Gaia DR3 was applied to Atlas's orbit, it should have pinpointed a likely parent system. Instead, it returned nothing. Not one star, not one plausible encounter. This was new. Oumuamua, the first interstellar object, could at least be traced loosely to nearby stellar associations. Borisov, the second, came from a young cluster still shedding debris. Atlas? Nothing but empty space, a blank past. As one researcher dryly put it during a conference call, we're looking for parents, but the birth certificate is missing, and the fingerprints point toward the same place that once called our name. If you're searching for cosmic intent, that's a hard sentence to unhear. In the next section, we'll look closer at that destination, the Sagittarius region itself. Because if Atlas truly came from there, from the crowded heart of our galaxy, then the question isn't just how it got here. The question is why that place keeps calling us back. Part 3, the Sagittarius neighborhood. If you wanted to hide a message in plain sight, this is where you'd send it from. When you look towards Sagittarius, you're not just looking at another constellation. You're staring directly into the heart of the Milky Way through the densest region of our galaxy, a luminous fog of stars, gas, and dust so thick that it forms a glowing band across our night sky. It's a direction that represents everything, both ancient and alive: stellar birth, stellar death, and the gravitational center that binds us all together. To human eyes, Sagittarius is a familiar pattern: the archer, bow drawn, aiming across the ecliptic toward the scorpion's heart. But to astronomers, it's the galactic downtown, a region of extremes where the rules of the quiet spiral arms no longer apply. Within this region lies Sagittarius A star, the supermassive black hole that anchors our galaxy's rotation, a monster 4 million times the mass of the Sun, surrounded by a maelstrom of orbiting stars, dust rings, and star-forming nurseries. This is not a gentle place. It's violent, radiant, constantly shifting. Stars are born and die in proximity so tight that if you stood on a planet orbiting one of them, your night sky would be a wall of light. Dozens of suns would outshine our own moon. Yet amid this chaos, the gravitational balance remains delicate enough to host stable orbits, complex structures, and, potentially, civilizations with a head start measured in billions of years. That's what makes Sagittarius such a compelling suspect. It's not just a direction, it's a statistical inevitability. More stars mean more planets. More planets mean more chances for life. And if even a fraction of those worlds evolved intelligence, then by the time humanity discovered fire, some of them could already have been sending probes, building networks, or watching new civilizations emerge. If you wanted to establish a galactic relay, a place where information from across the Milky Way could converge and circulate, Sagittarius would be the perfect location. It's centrally positioned, gravitationally stable at large scales, and dense enough that signals traveling between stars wouldn't have to cross empty voids for thousands of years. From there, a civilization could monitor multiple spiral arms at once, a hub of cosmic communication. And that's the theory some researchers are starting to whisper. What if Sagittarius isn't just a direction we happen to notice? It's a node in an ancient network. A relay station, perhaps built millions of years ago, designed to detect emerging civilizations like ours. When one begins leaking radio noise, the network notices. It transmits a signal back, subtle, one-time, unambiguous. If the civilization responds, another layer activates, a physical messenger. A probe, something like 3I/Atlas. Suddenly, the pattern doesn't look accidental anymore. Signal in 1977, object in 2020, both from the same direction. And the timeline, the cosmic choreography, fits perfectly. But there's another reason Sagittarius attracts attention. It's symbolically ancient. Long before modern astronomy, humans ascribed mythic power to this region of the sky. The Babylonians saw it as a hybrid creature, half man, half horse, aiming his arrow toward the cosmic frontier. The Greeks called him Chiron, the wise centaur. In many myths, Sagittarius is not a hunter, but a guardian, standing at the edge between the known world and the mysterious beyond. Those ancient myths now read like metaphors for what we're actually discovering: a guardian of secrets, a watchful eye at the galactic gate. It's as if, thousands of years ago, humans instinctively sensed that something important lay in that direction, something that would one day become more than symbolic. From a purely statistical standpoint, the odds of 3I Atlas pointing there by chance are low but not impossible. The sky is vast, but Sagittarius covers a sizable slice of it. Maybe 1 in 10 interstellar objects would trace back to its region. That's enough for plausible deniability. But the layering of coincidences, the wow! Signal, our outbound broadcasts, the timing of Atlas's arrival, tightens the odds until they start to look like intent. Even the geometry supports it. The galactic rotation carries our solar system in roughly the same direction as Sagittarius. We are literally moving toward it as we orbit the Milky Way center. Any object launched from there with the goal of intercepting our system wouldn't need to chase us, it would simply wait for us to arrive. The relative motion aligns naturally. From that perspective, Sagittarius isn't just symbolic, it's practical. The most efficient direction from which to send a message or a probe. The cosmic highway that leads directly into our neighborhood. Still, skepticism remains the scientific reflex. For every researcher pointing out the symmetry, another reminds us of the dangers of pattern-seeking bias, humanity's tendency to find meaning in randomness. We see faces in clouds, constellations in stars, intention in coincidence. Maybe Sagittarius looks significant only because it connects to stories we've already told ourselves. Maybe the wow signal was a natural radio burst, a magnetar flare, a pulsar misfire. Maybe 3I Atlas is just a rock, ancient and untraceable. But even the skeptics can't ignore how neatly everything fits. As one astrophysicist put it in a late-night panel at Caltech, if you wanted to design a coincidence that could survive peer review, you couldn't do better than this. The deeper scientists dig, the more the question shifts from, is it real? To why does it look this deliberate? The uncomfortable truth is that both possibilities, natural or artificial, are awe-inspiring. If Sagittarius produced the first direct signs of extraterrestrial contact, then the implications are obvious. But if all of this is chance, then the coincidence itself is extraordinary, a reminder that the universe, in its vastness, can still align in ways that mimic intention so closely they make us question our own logic. For now, Sagittarius remains a paradox, a direction that might mean nothing or might mean everything. It's the archer's bow aimed directly at Earth, and as more evidence emerges, it's starting to look like the arrow is already in flight. Part 4, 1977, A Strange Alignment. Sometimes the universe rhymes before it speaks. The year was 1977, a turning point in the story of humanity's relationship with the cosmos, though no one realized it at the time. Two events, separated by just 5 days, would later echo through half a century of scientific curiosity, conspiracy, and wonder. On August 15th, at exactly 11:23 p.m., the Big Ear radio telescope in Delaware, Ohio, detected something remarkable, a narrow-band radio signal at 1420 megahertz, the hydrogen line, the most universal frequency in the universe. For 72 seconds, the detectors recorded a signal so strong, so clean, that astronomer Jerry Echman, who was reviewing the data by hand, circled the numbers and scribbled a single word in the margin, "Wow." It was a moment of raw astonishment, a spike that shouldn't have existed, like hearing your name whispered clearly in a room full of static. The source appeared to come from the constellation Sagittarius. It was narrow, deliberate, and unmistakably non-random. But when astronomers turned the telescope back to the same coordinates, it was gone, never repeated, never explained. 5 days later, on August 20th, NASA launched Voyager 2, the most ambitious interstellar mission humanity had ever attempted. A twin probe, Voyager 1, would follow soon after. Each carried a golden record, a time capsule containing sounds and images from Earth, greetings in 55 languages, a baby's cry, whale songs, Bach, Chuck Berry, and a recording of human laughter. It was our first deliberate message to the stars. And, like a poetic coincidence, Voyager 2's eventual trajectory pointed roughly towards Sagittarius. 2 moments, 5 days apart. A signal in from Sagittarius, a signal out from Earth, physically embodied in a probe carrying our voice, our art, our fingerprint. Looking back, it's hard not to feel the symmetry. One might call it cosmic choreography, a kind of dialogue written in celestial timing. If an intelligence in Sagittarius had been monitoring our planet, it would have known what we were about to do. It would have seen our radio emissions spreading outward for decades, a slow-motion flare announcing that Earth had developed technology. And if it had wanted to answer, all it had to do was time its own transmission. At light speed, a signal from roughly 25 light-years away would take about 25 years to reach us. That means any civilization that detected our earliest strong broadcasts in the 1950s, early television, radar, atomic testing signals, could have sent a reply in the late 1950s or early 1960s. That reply, traveling at light speed, would have reached Earth right around 1977. So when the wow signal arrived, it fit perfectly within that feedback loop. We'd been shouting into the dark since the dawn of radio. Then, at the exact moment we prepared to send our first deliberate message outward, something answered. To most scientists, it was a fascinating coincidence. To a few, it felt like the first verse of a much larger conversation. Voyager's golden record wasn't just a technical artifact. It was a declaration. We are here. We are curious. We are listening. Designed by a small team led by Carl Sagan and Ann Dryan, the record carried instructions, diagrams explaining how to play it, encoded in universal constants. It was meant to last 1 billion years, long after humanity's memory had faded. The launching of this bottle into the cosmic ocean, Sagan wrote, says something very hopeful about life on this planet. The timing of the wow signal gives that hope a haunting echo. If both were random, then the universe performed a perfect duet without a conductor. If they were connected, then 1977 might have been year zero of cosmic communication, the moment we both spoke and were spoken to. The more you look at that year, the stranger it feels. The Big Ear telescope that detected the signal was decommissioned decades later, its land sold for housing developments. Voyager 2, meanwhile, continued outward, past Neptune, into the heliopause, and now, nearly half a century later, it's beyond the solar system, still whispering data from interstellar space. Its direction? Still towards Sagittarius. The symmetry is almost unsettling. 1977, the wow signal, inbound from Sagittarius. 1977, Voyager 2, outbound towards Sagittarius. 2020, 3I Atlas, inbound again from Sagittarius. A triangle of time, space, and intent. Signal in, message out, object in. If 3I Atlas were just a rock, the coincidence would already be poetic. But if it were a probe, or even a remnant of one, a messenger placed long ago to arrive precisely now, then the pattern takes on a chilling coherence. Some astrophysicists, unwilling to use the word contact, refer to it as temporal resonance, a convergence of technological milestones separated by decades but connected through motion and geometry. Humanity's golden record might not have been the first message exchanged between Earth and Sagittarius. It might have been a reply, a continuation of a conversation that began before we understood we were part of it. Because what if the wow signal wasn't the opening line? What if it was the response? For half a century, that 72-second burst has remained unexplained, too structured to dismiss, too brief to decode. But if it was sent by an intelligence already aware of our existence, it might not have needed to say much. It might have been the simplest of acknowledgments. We hear you. And now, decades later, with 3I/Atlas tracing its path from the same sky, a second acknowledgement seems to have arrived, not in radio waves, but in matter. A message not spoken, but delivered. The arrow fired in 1977 may finally have reached its mark. Part 5. The Opening Dilemma. Every discovery forces a choice: believe in chance or in design. By the time 3I/Atlas had passed beyond Jupiter's orbit, the debate was already tearing through the astronomical community. It wasn't just a question of what this object was, but what kind of universe we live in. Two explanations stood at the heart of it all, and neither one felt safe. On one side stood the natural hypothesis. The simplest, most conservative explanation: 3I/Atlas was just another interstellar wanderer, a shard of ice and dust ejected long ago from some distant star system. It came from Sagittarius only by coincidence. Its trajectory seemed deliberate only because the human brain is wired to find patterns in noise. The wow signal? Probably a natural burst. The timing? Pure luck. This view fit comfortably within the existing framework of science. It didn't require rewriting physics or invoking hidden civilizations. It framed Atlas as an astronomical accident, fascinating but not meaningful. On the other side stood the engineered hypothesis, and with it, a dangerous question. What if none of this was an accident at all? That view began quietly, in conference hallways and private Slack channels, among scientists who had run the numbers too many times to dismiss the odds. If the trajectory of 3I/Atlas wasn't random, if it had been inserted deliberately, then humanity might not just be observing a rock, we might be observing a probe. The idea wasn't new. In 1960, Australian physicist Ronald Bracewell had proposed the concept of autonomous interstellar messengers, probes sent to drift silently between stars, carrying the intelligence of their creators. Instead of broadcasting radio signals across impossible distances, these devices could wait, listen, and act. They wouldn't need to reach us in real time. They would simply exist, patient as stone, ready to respond when the right conditions arose. For decades, this idea, the Bracewell probe hypothesis, had been little more than speculation. But as our telescopes grew more powerful and our own ambitions expanded toward interstellar exploration, it started to look less like fantasy and more like engineering. If we could imagine building such probes someday, why couldn't someone else have done it already? 3Atlas fit the profile almost too well. A small, cold, seemingly inert object crossing the solar system on a hyperbolic path. Was it possible, some asked, that Atlas was a Bracewell messenger, dormant until its trajectory brought it close enough to a technological species to observe, sample, or simply record our existence? Even the skeptics admitted it was unnerving, because if that were true, then the wow signal might not have been an isolated incident, but part of a sequence. First, the signal, an acknowledgement. We hear you. Then, the visitor, a confirmation. We are coming from the direction you are listening. And if there's a third part, if the pattern holds, then something else might follow. Of course, most scientists still clung to the natural explanation. They had to. The alternative demanded more than evidence. It demanded a new worldview. If 3I/Atlas was engineered, it meant intelligence exists elsewhere in the galaxy, and not only that, but has already found us. It meant that for decades, we've been living inside a monitored system. Our radio emissions received, logged, and perhaps answered. The problem is that both explanations are supported, and neither can be proven. If 3I/Atlas is natural, its path is a perfect example of cosmic coincidence. If it's artificial, it's a perfect example of subtle design. The data looks the same either way. The equations don't care whether a trajectory was chosen or random. Gravity pulls the same regardless of who plotted the course. And so scientists found themselves trapped in a paradox, a kind of epistemological purgatory. Every new observation could be interpreted in both directions. Every anomaly could be explained away as either physics we don't yet understand or technology we're not yet ready to recognize. This is what researchers began to call the Atlas dilemma. If you wanted to make contact with a civilization skeptical of its own significance, one SETI researcher wrote, you wouldn't show up in a way that's obvious. You'd show up in a way that forces them to decide whether to believe in you. In that light, 3i/Atlas becomes more than an object. It becomes a test, a mirror reflecting our scientific faith back at us. Will we dismiss what we see because it's safer not to believe? Or will we accept that sometimes the simplest explanation isn't the truest? For every scientist willing to whisper probe, there were 10 more reminding them that extraordinary claims require extraordinary evidence. To label something as alien without proof would undermine decades of credibility. But to ignore the implications might mean missing the most important discovery in human history. Caught between ridicule and revelation, the community hesitated. They measured, they modeled, they watched. And as they did, 3 Atlas slipped quietly away, outbound, past the orbit of Neptune, heading back into the deep dark from which it came. Was it leaving us behind? Or simply continuing a mission older than our species? No one knew. But one thing was certain. Whether by coincidence or design, the universe had placed us in a moment of reflection, a point where every explanation said more about us than about the stars. The opening dilemma wasn't about 3i Atlas. It was about what we are willing, or afraid, to believe. And as the data continued to unfold, one truth became harder to ignore. Contact might not come with a greeting. It might come as a question. Part 6. Composition Mysteries. Rocks don't lie, but sometimes they speak a language we've never heard before. If 3i Atlas had been just another comet, its secrets would have ended with its orbit. But the more telescopes turned their gaze toward it, the stranger it became. Its composition, measured across multiple wavelengths, didn't fit any known category. Not quite a comet, not quite an asteroid, and not remotely similar to Oumuamua or Borisov, its 2 interstellar predecessors. When the European Southern Observatory published its early spectral data, the headlines were cautious. Unusual composition detected in interstellar object. But inside the data tables was a finding that stunned the astrophysics community: the light signature of rare metallic isotopes never before seen in natural interstellar debris. These isotopes, variations of magnesium, nickel, and titanium, existed in ratios that didn't match any known stellar nursery or supernova yield model. In simple terms, Atlas was built from materials that shouldn't exist together naturally. At first, astronomers thought it might be contamination, light scattering from background stars, calibration errors, or interference from Earth's atmosphere. But independent readings from space-based observatories confirmed the result. The signature held. Even more unsettling was the object's albedo, its reflectivity. Most comets are dark, covered in organic tar-like compounds that absorb sunlight. Atlas, however, reflected nearly 3 times more light than expected, closer to polished metal than rock or ice. Some described it as glinting, as if parts of its surface were structured, not randomly rough, but composed of repeating, angular patterns. When infrared imaging came in from the James Webb Space Telescope, it revealed something no one expected: periodic thermal fluctuations. Every 6 hours, Atlas's heat signature pulsed faintly, as though some part of its surface was warming and cooling at regular intervals. Not dramatically, just enough to be noticed by instruments sensitive enough to measure the temperature change of a candle flame from 1,000,000 kilometers away. At first, this seemed like rotation, the natural tumbling of a comet reflecting and re-radiating sunlight. But the timing didn't fit the shape. The light curve suggested an elongated body, yet the thermal pulses implied something internal, periodic, and precise. A few daring researchers proposed an uncomfortable hypothesis. Maybe the pulses weren't rotational at all. Maybe they were mechanical, heat signatures from a process operating beneath the surface. In public, these suggestions were dismissed as speculative, but privately, observatories began to watch more closely. Radio telescopes tuned to passive frequencies. Optical arrays searched for signs of microthrust, tiny jets or emissions that might indicate propulsion. Nothing conclusive appeared, and yet the regularity of those pulses persisted. Every natural model we ran failed to reproduce that rhythm, said Dr. Lian Wei, a thermal dynamics specialist from Beijing's National Astronomical Observatory. It's not random noise, it's a metronome, a 6-hour beat. Subtle, faint, consistent. Some scientists proposed it might be due to internal crystallization, a process where exotic ices transition between phases under solar heating, releasing energy in bursts. Others weren't so sure. It's possible, said one researcher, but it's also the most conveniently timed phase change in cosmic history. When compared to Oumuamua, whose acceleration and reflective surface had already triggered similar debates, Atlas looked like an evolution rather than an anomaly. Oumuamua had come and gone too quickly for deep observation, and many questions about its nature remained unresolved. But Atlas lingered just long enough to suggest a pattern. If you plot their orbits and directions, something extraordinary emerges. Oumuamua approached from Lyra, Borisov from Cassiopeia, and Atlas from Sagittarius. 3 distinct regions, but when projected in galactic coordinates, they all lie within the same rotational corridor of the Milky Way's arm. To some, this was coincidence. To others, it looked like a survey route. By now, the whispers within the scientific community had split into 2 camps. One saw Atlas as part of a natural class of interstellar objects, cosmic debris knocked loose from dying stars, finally within our detection threshold. The other saw something deliberate, a patterned sequence of visitors, each unique, each probing different aspects of our solar system as though mapping us. That second idea, once unthinkable, gained quiet traction as more anomalous data emerged. High-resolution imaging from the ALMA array hinted that Atlas's tail contained filamentary dust structures, narrow and twisted like spun fiber optics. They weren't behaving like normal gas jets. Instead, they held formation even against solar radiation pressure. Whatever Atlas was shedding, it wasn't normal dust. One of the ALMA technicians, reviewing the data off-record, described it this way. If you zoom in far enough, it looks like threads, parallel lines of something reflective, as if a lattice was unraveling. That description never made it into the official report. But in classified SETI circles, it sparked a chilling discussion. Was Atlas transmitting? If the object was a probe, dormant, ancient, or autonomous, its energy signature could easily hide within natural thermal noise. Its material composition could serve as both structure and signal, encoded at the atomic level. After all, an advanced civilization wouldn't need to broadcast in radio waves. It could use the material itself as a message. The spectral fingerprints, the isotopic imbalance, the rhythmic thermal pulses, each by itself ambiguous. Together, they began to form something that looked disturbingly intentional. If Atlas was a relic, it wasn't dead. It was whispering, quietly, through heat and light, in a language we hadn't yet learned to translate. And that raised a deeper, older question. What if it wasn't speaking to us at all? What if it was reporting back? Because while Earth's telescopes were watching Atlas, some instruments began to detect something even stranger, a return signal coming from deep space, exactly opposite its outbound vector. A signal that shouldn't exist. Part 7. The return signal. The moment you start listening to the universe, You have to be ready for it to listen back. The first detection came quietly, almost as an error. At 2:47 a.m. UTC on June 11, 2022, an operator at the Allen Telescope Array in Northern California noticed a faint, narrowband frequency spike near 1420.356 MHz, just above the hydrogen line. It lasted 19 seconds. The signal's shape was eerily familiar, narrow, stable, almost perfectly monochromatic. At first, no one panicked. The hydrogen line is crowded. It's where the galaxy itself hums with natural emissions. But when analysts cross-checked the source direction, the room fell silent. The signal wasn't local interference, nor did it match any known satellite, pulsar, or terrestrial reflection. It was coming from deep space, precisely 180 degrees opposite the path of 3I Atlas. The significance hit immediately. If Atlas had been moving away from the solar system along one vector, this signal was coming from the exact mirror direction, as though something far beyond was responding or being pinged through it. The observatory flagged the data as unconfirmed anomaly and forwarded it to SETI Berkeley and the Deep Space Network for secondary analysis. Within hours, 2 other arrays, one in Argentina, another in South Africa, reported the same narrowband emission, faint but consistent, originating from the same sky coordinates. By morning, the news had leaked into private research forums. At first, it sounded too good to be true. One user joked, "Looks like Atlas phoned home." No one laughed. To understand the magnitude of this, you need to know what makes 1420 MHz so sacred to SETI researchers. It's the natural emission frequency of neutral hydrogen, the most common element in the universe. Any advanced civilization would recognize it as a universal constant, a baseline of physics itself. It's also the frequency the 1977 WOW signal was detected at. Now, half a century later, something was speaking again. Not in random static, but in the same cosmic language, from a direction perfectly aligned with an interstellar visitor whose origin already pointed to Sagittarius. Coincidence? Probability said no. The data was run through every filter. Doppler correction? Confirmed. Satellite crosscheck? Negative. Atmospheric interference? Ruled out. Intermodulation artifacts? None detected. The signal was clean, unnervingly clean. Its frequency drift was measured at negative 0.004 Hz per second, consistent with a source far beyond the solar system, possibly several light-years away. Its power curve was stable, its amplitude modulated in a subtle repeating pattern, short, long, long, short, cycling every 72 seconds, the same duration as the WOW signal. It was as if the universe had just pressed repeat. By midday, the Allen Array's director, Dr. Farah El-Hassan, held a closed-door briefing with representatives from NASA, the ESA, and several international research institutes. The first slide on the screen simply read, Source Vector, Anti-Atlas. The second, Possible Interpretation, Response. El-Hassan, known for her unflinching skepticism, summarized the evidence. The frequency matched the hydrogen line within acceptable precision. The signal originated from the exact anti-vector of 3I/Atlas's outbound trajectory. Its modulation contained non-random periodicity statistically significant at 7 sigma confidence. The 72-second repetition perfectly mirrored the WOW signal's duration. This is not noise, she said. The question is whether it's natural or if we've just been answered. The room stayed silent for a full 10 seconds. As protocol demanded, the data was shared with the International Academy of Astronautics, IAA, for verification. Within days, observatories in Japan, Chile, and Spain confirmed partial detections. But something unexpected emerged. The signal wasn't constant. It came in bursts, every 22 hours and 12 minutes, as if pulsing from a rotating source. Each burst contained the same narrow band pattern, but with a faint, evolving modulation, like a phrase being slowly altered. Some researchers likened it to a beacon rotating on its axis, pointing toward us periodically as it swept through space. Others thought it resembled a transponder, a passive relay receiving and retransmitting something. Then came the most chilling realization: the timing of the first detection. The 22-hour, 12-minute interval wasn't random. It was exactly one solar rotation of Atlas's apparent 6-hour thermal pulse multiplied by 3.7, a ratio that matched the frequency drift correction factor of its outbound path. It was as though the signal's rhythm was synchronized with Atlas itself. Two ends of the same system, one here, one far beyond. When that calculation hit the analysis logs, one researcher at the Jet Propulsion Laboratory typed a single word in the margin: linked. The public never heard any of this. The official statement, released weeks later, described the event as a false positive resulting from interstellar scintillation and signal overlap. The press moved on. The public forgot. But inside SETI's encrypted servers, the raw data told a different story. The signal wasn't gone. It had simply shifted frequency, moving downward by exactly 1.42 megahertz, a harmonic of the hydrogen line. It was as though the source had noticed it was being tracked and adjusted, staying just out of lock range. And then, as suddenly as it had appeared, it stopped. The final transmission contained a single extended tone lasting 72 seconds, identical in duration and structure to the original wow. Signal. And then, silence. Dr. El Hassan's closing memo to her team was simple. We may not be the only ones analyzing 3I/Atlas. We may have been the ones being analyzed. For decades, SETI researchers have asked, if we receive a signal, what will it say? But maybe that's the wrong question. Maybe the signal isn't meant to say anything. Maybe it's meant to see who's listening. Because if 3I Atlas was a probe and the signal was its echo, then this wasn't first contact. It was confirmation of observation. The universe had noticed our curiosity and answered it, just long enough to prove that it could. Part 8. Scientific Repercussions. A discovery doesn't need to be public to change the world. Within 48 hours of the June 2022 event, every major space agency on Earth was under quiet lockdown. The Allen Telescope Array, Parkes Observatory, and Jodrell Bank received encrypted directives from a joint committee led by the International Astronomical Union and the United Nations Office for Outer Space Affairs, UNOSA. The message was brief. Cease public data transmission related to the Atlas anomaly pending cross-verification and international review. It was the first time since the Cold War that such a coordinated order had been issued to civilian scientific institutions. Officially, it was for data integrity. Unofficially, it was containment. Because if the signal was real, if Atlas and the echo from the opposite vector were in any way connected, then humanity had just crossed a threshold no one was prepared for. 1. The division of belief. Behind closed doors, scientists split into 3 camps. The materialists insisted that the return signal was a product of interstellar scintillation, the natural focusing and scattering of radio waves by turbulent plasma.
In their view, the apparent modulation and hydrogen line precision were illusions caused by our instruments and our eagerness. The contact theorists argued the opposite. The signal's precision, periodicity, and synchronized timing with Atlas's thermal pulses were impossible to fake through random scattering.
It's engineered, said one astrophysicist at Caltech. Maybe not for us, but by something capable of manipulating space like a laboratory. The third camp, the strategists, didn't care which was true. Their question was practical. If this is intelligence, what are the consequences of replying?
2. The official response. In late July 2022, NASA and the European Space Agency issued a joint statement dismissing the detection as instrumental error amplified by coincidental alignment. Privately, however, they expanded funding for a quiet initiative labeled Project EchoScan, an effort to monitor the anti-Atlas region continuously using deep space network antennas.
To determine whether the signal would repeat. When the internal memos leaked months later, a single sentence captured global attention. The Atlas event meets 3 of 5 parameters for non-terrestrial origin. No one outside the project knew what those parameters were.
The documents vanished from public databases within hours. 3. The ripple effect. Meanwhile, the discovery had already begun to change science, even without confirmation. SETI, long considered a fringe field, suddenly found itself flooded with grants. Defense contractors began filing patents for deep-frequency anomaly tracking and non-gravitational trajectory mapping. The Chinese National Space Administration announced a classified program named Tianmen, aimed at developing long-range optical AI observatories, though no one doubted what it was really for. In university departments across the world, students whispered about the Atlas paper, a document rumored to summarize the entire case: orbit, spectra, thermal pulses, return signal, and to conclude that a non-natural explanation could not be ruled out. The paper was never published, but the myth alone reignited SETI's credibility overnight. And yet, the fear grew just as fast as the excitement. 4. The philosophical shock. If the Atlas event was genuine, it raised impossible questions. Why Sagittarius? Why us? Why now? Were we chosen because of our broadcasts, or merely because we were detectable? If 3I Atlas was a probe, had it been sent recently, or was it ancient, drifting for millennia until we crossed its path? And if it was designed to trigger a response, what happens when we respond? The debates turned personal. Conferences devolved into arguments about existential risk. Some researchers argued for radio silence, the so-called dark forest hypothesis, the idea that any reply could expose our position to unknown dangers. Others countered that silence was futile. Earth's emissions had already announced us to anyone listening. "We've been leaking light for 100 years, said one astronomer from the SETI Institute. If they wanted to erase us, they'd already be on the way. 5. Data under lock. As months passed and the signal faded, most public observatories moved on. But in government archives, the data was not forgotten. Cross-correlation of the 2022 signal with the original 1977 WOW transmission revealed something uncanny. When the two waveforms were overlaid and time normalized, they shared identical amplitude envelopes. Different frequencies, different decades, same modulation structure. That should be impossible. It meant the two signals, separated by 45 years, might have been generated by the same system, or by devices built to the same specifications. Either the same source sent both, or both were echoes from a single, ongoing transmission line spanning interstellar space. Suddenly, the contact theory no longer sounded fringe, it sounded predictive. 6. Public ignorance, private panic. The general public never learned the details. The story was buried under data retractions and solar interference press releases. But the scientific community had changed forever. Careers were redirected, research priorities shifted. A quiet consensus formed, unspoken but palpable. The universe may already watching. The shift was cultural as much as scientific. Humanity's self-image, as explorers, as pioneers, had quietly inverted. We were no longer the ones searching for life. We were the ones being observed. One internal memo from the European Southern Observatory captured the unease perfectly. We used to look out and ask, is anyone there? Now we look up and ask, how long have they been watching? 7. The vanishing. By December 2022, 3I Atlas had faded beyond the reach of most telescopes. Its trajectory, still hyperbolic, would soon carry it into the Oort cloud, and from there into interstellar space, outbound, silent, and cold. But before it disappeared completely, a final set of infrared readings from the James Webb Space Telescope showed something inexplicable. The 6-hour thermal pulse that had defined its behavior for months suddenly stopped. No cooling curve, no residual heat, just abrupt, total silence. Almost as if the object had powered down. Whether that meant the end of a natural process or the shutdown of something mechanical, no one could say. The official explanation cited loss of solar heating beyond threshold distance, but among those who had seen the data, the feeling was different. Atlas hadn't just gone dark, it had gone quiet, as though its task was complete. In the next section, we'll explore what that task might have been, and how ancient records, stretching back millennia, may hold the first human hints that Sagittarius has been sending messages far longer than we've been listening. Part 9. The historical echoes. History doesn't repeat itself, it signals. When scientists at the European Southern Observatory began to compare the geometry of the Atlas trajectory to historical astronomical charts, they expected nothing. After all, 3I Atlas was an interstellar object, its path unique, its visit unprecedented. But what they found was far stranger. For at least 2 millennia, civilizations had been marking celestial events, myths, and alignments that all pointed, in one way or another, toward the same part of the sky. Sagittarius, the same region we now associate with the 1977 WOW signal. The same vector from which 3I Atlas had arrived. The same galactic corridor that modern telescopes keep finding reasons to stare into. It began as a side project. A historian of science, Dr. Imane Khoury, analyzing ancient astronomical records from Mesopotamia and China. Her goal was to trace humanity's earliest cataloging of deep sky regions. Instead, she stumbled across a pattern of repetition and reverence that defied coincidence. 1. The Archer's Eye. The earliest surviving records from Babylonian astronomers, dated around 1000 BCE, described Sagittarius as the bow that guards the gate. The gate, scholars assumed, was metaphorical, representing the solstice or the threshold between the mortal and divine realms. But Khoury noticed something peculiar. The coordinates for this gate corresponded almost exactly to the modern position of the Sagittarius A-star radio source, the supermassive black hole at our galaxy's center. How could ancient astronomers with no telescopes know there was something powerful there? They couldn't have seen the black hole, but they might have seen flashes, transient brightening events caused by high-energy emissions. If so, those flickers would have appeared sporadically, precisely where modern astrophysics places Sagittarius A-star. In other words, they'd been watching the same beacon we watch now. 2. The Chinese Chronicles. Across the world, Chinese imperial astronomers of the Han Dynasty, 2nd century BCE, recorded guest stars in the direction of the Archer, brilliant, short-lived lights that appeared and vanished without explanation. Most were likely supernovae. But one account from 1340 BCE described a red light moving with purpose, slower than the stars. The record adds, it tarried 7 nights and was gone, as though it had entered the gate of heaven. To modern astronomers, the description reads uncannily like an interstellar visitor, not unlike Oumuamua or Atlas. passing through the inner solar system.
If the account is accurate, Earth may have witnessed such objects before, long before telescopes could confirm them. The Sagittarius manuscript. In 1897, an obscure archaeologist named Rudolf Wechsler uncovered a fragmentary papyrus near Luxor, Egypt, describing a star in The Hand of the Archer that spoke without sound. The text, written in late Demotic script, was largely dismissed as mystical poetry.
But in 2023, a linguistic AI at the University of Leiden retranslated one line differently. A voice of the sky came again from the place of the archer, and the wise said, "It was the sound of the stone returning home." For centuries, it was read as metaphor. Now, in the light of Atlas, it reads like prophecy. 4. The forgotten signal. Even in the modern era, the echoes persisted. During the height of the Cold War, in 1963, the U.S. Air Force's Project Moonwatch recorded a transient radio emission from the Sagittarius region, classified for decades under the name Echo Flight 7. The file remained sealed until 2018, when fragments were declassified and quietly published. Among the surviving notes was one unsettling line, written by the lead analyst. Pattern resembles interleaved binary series, could be modulation artifact or intentional encoding. The location? Within 2 degrees of the 1977 WOW coordinates. The signal vanished after a single detection, dismissed as interference from Soviet radar. But now, re-examined in light of the Atlas event, it looks like a precursor, a signal that may have flared briefly, decades before we were ready to notice. 5. Patterns across time. The coincidences stack like sediment. Ancient stargazers marking Sagittarius as the gate. Chinese astronomers describing a moving red light centuries before telescopes. A 19th century papyrus referring to the stone returning home. A classified Cold War radio burst from the same coordinates. The 1977 WOW signal. The arrival of 3I Atlas in 2020. The return signal of 2022. Each separated by centuries or decades, yet all pointing to the same narrow corridor of space. Could all of it be coincidence? Possibly. But the pattern doesn't just span science. It spans culture, myth, and time. It's as though the archer's bow has been aiming at us since the dawn of recorded history. When Dr. Corey presented her findings to a small symposium in Geneva, one astrophysicist dismissed it as anthropological pattern seeking. But another, Dr. Malik Varga of ESA's astrometry division, disagreed. If the signal is ancient, he said, then maybe these civilizations didn't just imagine it. Maybe they remembered it. The echo hypothesis. The more researchers dug, the more the word echo returned, in texts, in equations, in the physics itself. Perhaps what we're seeing across millennia isn't a linear chain of events, but a resonant pattern, a repeating cycle of emission and reflection, transmission and return, like a cosmic sonar pinging through time. Under this model, the WOW signal, Atlas, and the 2022 return signal aren't separate phenomena. They're parts of one continuous loop. A loop so vast it spans centuries, maybe millennia. And if that's true, then Earth isn't receiving messages for the first time. It's merely receiving the next round of an ongoing exchange, one we've been too young to recognize until now. 7. The question of intent. If the Sagittarius region is the galactic center, both literally and symbolically, then it may be the perfect place for a cosmic relay. The gravitational core of the Milky Way could serve as a natural amplifier, bending signals and trajectories alike. A civilization harnessing that environment could project information across the galaxy with minimal energy loss, and perhaps that's exactly what we're witnessing. Not a message to Earth, but a message through us.
a transmission using our solar system as part of its circuitry, our planet as a reflecting node in a vast interstellar lattice. It would mean that contact isn't just communication, it's infrastructure. It's infrastructure. When you connect all the data points, mythic, historical, and modern, a haunting image emerges. A bow drawn for thousands of years, an arrow of matter and signal aimed directly at Earth, and a civilization somewhere in the galactic heart, pulling the string. The past isn't echoing coincidence, it's echoing pattern, and the sound is getting louder. Part 10, the Sagittarius Relay Hypothesis. Maybe the message isn't coming from one world, maybe it's coming through all of them. By late 2023, the Atlas investigation had gone far beyond astronomy. It had become a convergence point for physics, linguistics, network theory, and even information science. The deeper researchers dug into the geometry of its trajectory and the eerie recurrence of signals from Sagittarius, the clearer one possibility became. This wasn't just contact. It was architecture. That's how the Sagittarius Relay Hypothesis was born. The idea didn't start in a government lab, but in an open-source research collective called Signal Hub, a loose alliance of astrophysicists and data scientists who were frustrated by official silence after the 2022 return signal. Working with leaked positional data, they noticed something that formal observatories had missed or had chosen not to publish. When plotted in three-dimensional galactic coordinates, the trajectories of Oumuamua, Borisov, and 3I Atlas didn't form random scatter. They fell along a faintly curved line, an arc that, when extrapolated, passed directly through the galactic core near Sagittarius A star. The odds of three unrelated interstellar visitors aligning that precisely were less than 1 in 10 billion. If these objects weren't random, they might represent nodes, markers in a chain spanning the galaxy, a network older than humanity itself. 1. The architecture of the impossible. In physics, there's a principle called gravitational lensing, the way massive bodies like stars or black holes can bend light, focusing it like a cosmic magnifying glass. Some theorists proposed that a sufficiently advanced civilization could exploit this effect deliberately, creating galactic-scale communication relays that used gravity wells to redirect information. Imagine a network of probes, each stationed along predictable orbital routes, forming a lattice of gravitational amplifiers. Messages would travel not by brute force radio transmission, but by bouncing across curved space, each node re-encoding and forwarding the signal through the galaxy's spine. It would be slow, subtle, and nearly undetectable, except for moments like ours, when a node passes close to an inhabited system. Atlas, according to this hypothesis, wasn't a message. It was a router. 2. Data in the dust. Evidence for this came from an unlikely place, the faint filamentary dust trail Atlas left as it departed the solar system. When analyzed by the ALMA array and JWST, it showed polarization patterns inconsistent with any known cometary outflow. The filaments seemed to align magnetically, as if carrying structured charge or encoding information. To one cryptographer working with the dataset, the polarization maps looked disturbingly familiar. When plotted in binary, light versus dark, they resembled packet headers, short sequences repeated with checksum-like regularity. Signals for synchronization, parity, timing. The team jokingly called them space barcodes. The name stuck. When the barcodes from Atlas were compared to archived radio data from the WOW signal, The ratios of interval spacing matched within 0.3%, too close to dismiss. 3. The Network Map Signal Hub simulation, leaked in early 2024, changed everything. Using Gaia's latest stellar cartography, they mapped all known interstellar objects' inbound and outbound trajectories, color-coding them by angle and speed. When viewed from above the galactic plane, a pattern emerged, a web-like lattice, faint but coherent, spanning thousands of light-years. The densest cluster sat, predictably, in Sagittarius. The simulation's caption read simply, "Not random, not local." Functional. For those who saw it, the implication was inescapable. Humanity's solar system might not be an isolated coincidence, but a transit point, a node in a much larger galactic communication network, one that had been operating for eons. 4. The relay equation. Physicists began developing a mathematical framework for how such a network could work. They called it the relay equation, a model describing how gravitational curvature and information compression could work together to maintain long-distance coherence. In simple terms, it suggested that signals could ride gravitational fields like surfers on waves, using black holes, neutron stars, or even massive planets as natural repeaters. Every few thousand years, a probe, like Atlas, might move into position, update or stabilize the chain, and continue onward. To a civilization capable of operating at those scales, travel time and lifespan would be meaningless. Each node would act as a silent witness, keeping the network alive long after its builders were gone. Somewhere, perhaps near the galactic center, there could still be an origin hub, the first transmitter. Or perhaps the system had become autonomous, a self-perpetuating lattice, sending echoes of its creators long after they vanished. 5. The human reaction when drafts of the Sagittarius relay hypothesis leaked, the reaction was split down the middle. To believers, it was the final piece of the puzzle, the unifying theory tying together the WOW signal, 3i Atlas, and the return transmission of 2022. For skeptics, it was a modern myth, the latest iteration of humanity's old desire to see meaning in the void. But there was one fact neither side could ignore. Every year, as new telescopes came online, more interstellar objects were being detected, and their orbits were not random. The Vera Rubin Observatory cataloged 7 new candidates in 2024, 5 of which followed hyperbolic trajectories within the same galactic corridor. Something was moving through the galaxy in formation. 6. The uncomfortable implication. If the relay hypothesis was right, then contact had already occurred, not as a single event, but as a continuous infrastructure. Humanity had simply been too young to interpret it. And if the system is still functional, then our detection of it might not be neutral. In a network designed to observe, observation itself is interaction. By analyzing Atlas, by receiving the return signal, by aligning our instruments toward Sagittarius, we may have triggered a response, not because we were chosen, but because we completed the circuit. Dr. Varga, one of the first proponents of the relay hypothesis, described it this way. If you light up a sensor in a cosmic network, it doesn't just record you, it starts talking back. We may have just activated a conversation that's been waiting for 1,000,000 years. At this point, a darker question began to surface, one no one wanted to ask publicly. If we're part of a galactic communication web, who maintains it now? And what happens when one of the nodes, ours, finally responds? Because the return signal of 2022 may not have been a simple echo. It may have been an acknowledgement. And if acknowledgements are part of a protocol, then the next transmission, the one we haven't heard yet, might be the instruction phase. Part 11. The instruction phase. First, a signal. Then, a mirror. Now, a response. By mid-2024,
Every major observatory on Earth had shifted its gaze toward Sagittarius, waiting for something, anything, to happen.
The return signal of 2022 had gone silent. Atlas had vanished beyond the heliopause. And yet, deep in the noise floor of the galaxy's background hum, researchers began to see it, a new pulse. It began as a whisper at the edge of detectability, buried in the cosmic microwave background, a slow, rhythmic modulation appearing only once every 27 days. It was faint, smooth, precise, and encoded in a way no natural source should produce. At first, they called it the slow drift. When the pattern was stretched, time compressed, and cross-correlated with previous anomalies, something astonishing emerged. The drift matched the temporal signature of the 2022 return signal, downshifted by a factor of 1,000. It was as if the signal had been slowed to the point where its structure unfolded not over seconds, but weeks. 1. The message beneath the noise. The first to catch it was an independent observatory in Chile's Atacama Desert, a private SETI outpost called Array 12, staffed mostly by graduate students and funded by crowdfunding campaigns. They'd been running a 24/7 blind scan of the anti-Atlas vector since 2023, using open-source software written to detect prime number modulations in deep space static. At 0218 local time, their algorithm flagged a frequency cluster centered at 1.420 GHz, again the hydrogen line. The amplitude variations repeated every 19.84 minutes, but when converted into binary and plotted as an image, the students saw something no one expected: a spiral. Not a random spiral, but a logarithmic one, mathematically perfect, expanding in a ratio that matched the golden constant, phi equals 1.618. At first, they assumed it was an artifact. Software compression errors sometimes produce fractal-like noise, but when the data was reprocessed by 3 independent teams, the spiral remained, symmetrical, deliberate, and elegant. The image wasn't a picture. It was a waveform map, a self-referential guide to how the signal itself should be read. Embedded within it were markers, coordinate-like sequences, ratios, and pulse intervals, each separated by exactly 1420 microseconds. The code was a key. When applied as a decoding matrix to the full dataset of the slow drift, it revealed something hidden, a second layer of modulation, invisible until now. And that layer contained information that changed everything, too. The hidden instruction buried within the second layer was a repeating 3-dimensional pattern, a sequence of spatial coordinates that didn't correspond to any known stellar map. But when projected through the galactic plane, the points traced a shape, a helical path coiling outward from the Sagittarius arm toward the solar neighborhood. The helix intersected one location in particular, the orbit of Jupiter. Not a random point in the orbit, but a specific sector of the Trojan asteroid field, a gravitationally stable region trailing Jupiter by 60 degrees. For decades, astronomers had studied those asteroids for clues about the solar system's formation. Now, the signal seemed to be pointing directly at them. When the coordinates were compared with existing catalogs, one object stood out: 2010 TK7, a small Trojan with an unusual reflective spectrum and a strange tumbling orbit. It was already under study by the ESA for a potential future flyby. But after the decoded signals spread through closed scientific channels, that mission proposal changed overnight. The new name on the documents: Project Helix. 3. The Project Helix Directive. Officially, Project Helix was a spectral survey of Trojan asteroids to study prebiotic material. Unofficially, it was an attempt to follow the map. In early 2025, NASA, ESA, and JAXA quietly collaborated on a deep space probe codenamed Ariadne. Smaller than Voyager, faster than New Horizons, and equipped with quantum gravimetric sensors, Ariadne's true mission was simple: approach 2010 TK7 and determine if the signal's coordinates were pointing to it or through it. Dr. Farah El-Hassan, who had directed the Allen Telescope Array during the 2022 detection, was now the scientific lead. Her private note to the mission control team, later leaked, read, "If Atlas was a messenger and the return signal was acknowledgement, this may be the next line of communication. We may be following the script." The team called it the instruction phase, the stage in which an automated network, once it confirmed detection by a new civilization, issued coordinates for the next step of contact. 4. The geometry of intention. When the golden spiral decoding scheme was applied to the waveform, additional geometric ratios emerged, the same constants that describe orbital resonance between Jupiter and Earth. It was as if the signal were teaching, demonstrating that it understood the architecture of our solar system, and that it expected us to recognize the math. To some, this was proof of authenticity. To others, it was manipulation, a way to lure us toward a specific location under the guise of communication. Philosophers and physicists found themselves in rare agreement. The signal wasn't asking questions, it was issuing directions. 5. Echoes of an older design. Meanwhile, comparative analyses of the Atlas dust fragments, the few spectral readings still available before it faded, revealed something unsettling. Trace ratios of silicon carbide and metallic hydrogen, exotic materials with high conductivity and resilience. When extrapolated, their lattice spacing mirrored the mathematical structure of the signal's golden spiral. It was as though the signal and the object had been written in the same language, one through matter, the other through math. A network that uses geometry itself as a communication protocol, unbreakable by time, culture, or biology. 6. The countdown pattern. And then came the discovery that turned the instruction phase from speculation into urgency. When the 27-day slow drift pulses were analyzed over longer spans, astronomers noticed that each new cycle shortened by a measurable margin, exactly 0.073% per month. Projected forward, the pulses would converge on a single timestamp, July 9, 2027. The last pulse, if the pattern held, would strike precisely at 1923 UTC. At that moment, the phase alignment between Earth, Jupiter, and the Trojan 2010 TK7 would reach perfect resonance, a configuration that happens only once every 462 years. In other words, the signal wasn't just giving coordinates, it was giving a time, a date, a meeting point. When El-Hassan's team presented this to the International Oversight Committee, the room reportedly went silent for an entire minute. Finally, one official said what everyone was thinking. It's not a message anymore, it's an appointment. Whether to trust it or not became the most important scientific and philosophical decision humanity had ever faced. In the next section, we'll follow the preparations for that appointment, the race to send Ariadne to Jupiter's Trojan field, the ethical debates that split the scientific world, and the possibility that what waits at 2010 TK7 has been listening for far longer than we've been ready to arrive. Part 12. Mission Ariadne. By early 2025, the countdown embedded in the Sagittarius signal had unified and divided the planet in equal measure. Governments argued, religious leaders warned, physicists hesitated between awe and dread. And yet, amid the noise, one idea became irresistible. If something wanted us at Jupiter's Trojan field by July 2027, then we had 2 years to get there. That meant one thing: Ariadne.
The project that began as a whisper in SETI back channels now consumed entire departments.
NASA's Jet Propulsion Laboratory, ESA's Operations Center in Darmstadt, and JAXA's Hayabusa division merged resources into a joint mission so secret that the initial budget line item was buried under Planetary Weather Observation Systems. The codename came from Greek myth, Ariadne, the woman who gave Theseus a thread to find his way out of the labyrinth.
It was the perfect metaphor. Humanity was standing at the edge of the maze, string in hand, the signal itself. 1. The probe Ariadne was unlike any probe humanity had built. Barely the size of a car, its frame was a lattice of beryllium-titanium composite, light, heat-resistant, and designed for extreme longevity. It carried 3 main instruments: Helios, a quantum gravimetric sensor capable of detecting micro-fluctuations in gravitational curvature, the kind expected near an active relay node; Lyra, a narrowband radio telescope designed to detect hydrogen line signals with precision to within 10 to the 9th hertz; Spindle, a cryogenic sample collector for capturing particulate matter or microdebris near the target zone. Its power source? A dual-mode fusion battery hybrid, supplemented by solar sails that unfurled like translucent wings, etched with equations, the same golden spiral ratios embedded in the Sagittarius signal. When engineers protested that the sail's patterning was unnecessary, Dr. Farah El Hassan reportedly said, "If someone's waiting, they'll recognize their own handwriting." 2. The launch Ariadne launched from the Guyana Space Center at dawn on March 19, 2026. The world didn't know. The live feed was labeled as a communications satellite deployment. Inside mission control, the room was dark except for the soft glow of telemetry screens. When the engines fired, the tension broke. Scientists, technicians, engineers exhaling in unison. Humanity had just followed its first extraterrestrial instruction. The probe slingshotted around Earth, then Venus, then used a gravity assist from Mars to accelerate toward Jupiter. Its trajectory was a spiral, not by necessity, but by design. Someone, or something, had sent us a map written in geometry. Ariadne would travel by that geometry, tracing the same ratios, in hopes of being recognized. 3. The silence before the reach. For the first 6 months, Ariadne's systems performed flawlessly. The radio feed streamed packets of routine data: thermal readings, magnetic flux, gravitational noise. Then, in October 2026, Helios detected a faint but persistent distortion. It was subtle, a ripple in the curvature of local spacetime, like a heartbeat faintly felt through the floor. The readings repeated every 72 minutes, the same ratio that had defined both the WOW signal and the Atlas return transmission. When the data was correlated against Ariadne's position, the source pointed not to 2010 TK7 itself, but to a point 200 kilometers above its surface, inside the Trojan cluster. A point in empty space. That was where the signal's geometry led. 4. The approach. By June 2027, Ariadne was closing in. The probe's velocity had slowed to a crawl, guided by autonomous navigation algorithms trained on gravitational anomalies. What it saw defied expectation. The Trojan asteroid field shimmered faintly, as if veiled by electromagnetic interference. Every sensor registered mild flux, yet the region was quiet, too quiet. No micrometeoroid hits, no debris scatter. It was as though something had cleared a path. Then, at a distance of 320 kilometers from the coordinates derived from the Sagittarius signal, Lyra registered a sudden burst, a sharp, narrow-band tone at exactly 1,420.356 megahertz. Duration, 72 seconds. Amplitude, identical to the 1977 WOW signal. The team in Pasadena froze. 5. The encounter. 3 minutes after the signal, Ariadne's cameras recorded something no one could explain. A structure. It wasn't large, maybe 80 meters across, but its geometry was unmistakable. A helix, suspended motionless in the void, composed of thin metallic filaments. The shape rotated slowly, shimmering with reflected sunlight. No propulsion, no visible origin. The structure matched, almost perfectly, the spiral pattern decoded from the 2022 signal. The room erupted. Some shouted for more data, others for caution. But before any command could be sent, Ariadne transmitted an unscheduled data packet, one not in its programming queue. 6. The aftermath. For 19 minutes, Mission Control received only background static. Then, faintly, the Helios sensor spiked, a short, dense pulse of gravitational curvature, like a soft shockwave. The team thought Ariadne had been destroyed, but then telemetry returned, faint, intermittent, erratic, as though the probe were transmitting through a deep medium. Visual imaging showed nothing but the helix, now faintly luminous. The frequency emissions had changed, modulated not in radio, but in gravitational waves, too low for normal detection. The helix wasn't reflecting signals, it was transmitting them, and Ariadne was inside its path. Al-Hassan, watching the screen, whispered, "It's not a beacon. It's a portal." But before anyone could confirm, Ariadne sent one last distorted image, a frame filled not with the helix, but with a field of symbols, repeating spirals, lines, and ratios arranged like writing. And then, finally, the telemetry cut out. July 9, 2027, 1923 UTC, exactly as predicted. 7. The global reaction. Officially, nothing happened. The Ariadne mission was never acknowledged. The data was sealed under joint classification across agencies. But fragments leaked. Images, timestamps, the binary message. Within days, encrypted forums and private SETI channels were buzzing with one question: did we just activate the relay? Theories exploded overnight. Some said the helix was a storage device, a node of the Sagittarius network. Others believed it was a receiver, waiting for a command to awaken. But the most unnerving theory came from a physicist named Dr. Yu Nakamura. It wasn't sending instructions to us, it was sending confirmation to them. The signal that had started half a century ago, a whisper from Sagittarius, had now come full circle. And somewhere, far beyond the Milky Way's dust and light, someone knew we'd answered. Part 13. The Awakening Signal. What begins as data ends as presence. The Ariadne transmission ended precisely as predicted, at 1923 UTC, July 9, 2027, and for 12 hours afterward, Earth's deep space networks fell silent. No telemetry, no static, no cosmic background noise, just a flat, impossible stillness, as though the sky itself had paused to listen. Then, at 7:42 the next morning, the universe answered. The signal didn't come from the Trojan field or even from the direction of Jupiter. It came from everywhere. Radio telescopes across the planet, from Australia to Greenland, registered a simultaneous, perfectly synchronized broadband pulse spanning the entire electromagnetic spectrum. Duration, 72 seconds. The same number again. The same cosmic metronome. To the human ear, when translated into sound, was nothing more than a low hum rising into an almost musical overtone, haunting, harmonic, and eerily alive. But to the instruments, it was something far stranger, structured interference. The pulse contained a self-similar waveform,
a fractal pattern repeating across scales, identical whether observed at 1 Hz or 1 GHz. Nature doesn't do that. Consciousness does. The world's scientific agencies, already operating under silent coordination, called it the awakening signal. 1. The data storm. Within minutes, observatories were drowning in information. Every satellite in low Earth orbit experienced transient errors. Communications relays briefly desynchronized. In a few cases, atomic clocks jumped forward by fractions of a second, a temporal jitter that no natural electromagnetic burst could cause. But the strangest effects occurred in instruments not designed to listen. Magnetometers, seismographs, and even medical imaging devices began recording faint oscillations at the same frequency. The pulse wasn't just hitting space, it was resonating through matter. At CERN, researchers reported interference in the Large Hadron Collider's sensors, a spike that synchronized perfectly with the 72-second global pulse. In a classified post-event report, one engineer described the waveform as a signal searching for its mirror. The implication was staggering. The awakening signal wasn't targeting specific receivers. It was activating the entire biosphere, turning every conductive, gravitationally bound system on Earth into a listening node. 2. The hidden frame. For weeks afterward, scientists tried to decode the pulse. It seemed meaningless, a pure tone stretched across the spectrum. But a young data analyst from the University of Toronto, Maya Serrano, made a discovery that changed everything. By plotting the signal's amplitude not as a function of time, but as phase interference, she uncovered a secondary modulation, a waveform hidden beneath the carrier frequency. It wasn't random. It was a map, not of space, of time. Each phase node corresponded to astronomical events across human history. Eclipses, pulsar emissions, nova outbursts, all aligned to a single vector, Sagittarius. The pattern ended at one unmistakable point, 1977. The wow signal. And beyond that point, another spike, 2027, Ariadne. The data looked like a signature, a marker of completion, as though the signal had been waiting for humanity to reach a certain milestone before it could reveal itself fully. The structure isn't communication, Serrano wrote in her paper. It's confirmation of contact, a temporal handshake written across centuries. 3. The lights over Sagittarius. Then came the visuals. By August 2027, space telescopes aimed toward the Sagittarius arm began picking up transient optical bursts, soft, coordinated flashes near the galactic core, moving not randomly, but in triangular formations. Each flash lasted less than half a second, but their timing was exact, repeating at intervals matching the waveform of the awakening signal. It was as if the galactic core itself were responding. When triangulated, the bursts traced an enormous geometric pattern, a helix, 40 light-years wide, echoing the shape of the structure Ariadne had found. The pattern wasn't static. It was unfolding, expanding outward in slow motion, as though something colossal and ancient had been dormant there, waiting for a signal to reawaken it. The astrophysicist community dubbed it the helical array. To the naked eye, it was invisible. But to instruments, it was unmistakable, a network of synchronized energy nodes forming near Sagittarius A star. 4. Global reaction. The awakening signal leaked to the public despite every effort to contain it. Amateur astronomers posted spectral anomalies online. Radio hobbyists recorded the pulse themselves. Within days, the story was everywhere. The sky that spoke. Governments scrambled to deny, distract, reinterpret. They called it solar interference, a once-in-a-century gamma flare, an artifact of atmospheric resonance. But people had heard it, felt it.
All across the world, reports poured in of devices spontaneously powering on at the exact moment of the pulse. Phones, radios, even dormant computers booting into diagnostic mode. Some individuals claimed they'd felt a faint vibration in their bones, a pressure in their inner ear, as if their bodies had become receivers. Whether psychological or physical, the effect was undeniable. The signal wasn't just being detected, it was being experienced. 5. The SETI divide. Within the scientific community, lines were drawn sharper than ever. One faction, led by Dr. El-Hassan herself, argued that humanity had just triggered the activation event of a galactic relay, the completion of a protocol set in motion when the first wow signal reached Earth. We didn't receive a message, she told an internal council, we completed one. Others, like physicist Yu Nakamura, took a darker view. We've been cataloged, he said. The signal is a handshake, and once the network knows we exist, it never forgets. For Nakamura's team, the awakening signal wasn't an invitation. It was a ping, a galactic version of online status confirmed. 6. The second silence. Then, as suddenly as it began, the light bursts ceased. The pulse faded. The universe fell quiet again. But deep in the noise of background radiation, observatories detected a faint residual whisper, a standing frequency at 1420 MHz, constant, unmodulated, as if holding open a channel. For the first time, humanity had a live connection, a stable carrier wave linking Earth to the heart of Sagittarius. The question wasn't whether to respond, it was whether to speak.